You might be reading the title and thinking, I already kind of have a GitOps model for cloud infrastructure. I use Terraform and the code is stored in Git repository. I use pull request based automation such as Atlantis. But is the state stored in Git? The key fundamental of GitOps model, the source of truth should be stored in Git. With infrastructure as code tools such as Terraform, the state is usually stored in an external source such as an S3 bucket in AWS. Terraform is only ever fetching or refreshing the state once Terraform plan or Terraform apply is initiated. Now, this can create a diff between actual resources deployed to the cloud and what Terraform is declaring in the code. Would it not be better if the cloud infrastructure such as S3 buckets, EC2 instances, or RDS databases could be declared through easy-to-use YAML files with the source of the truth being stored in Git? This would be similar to deployment model that most users are doing with the application level of Kubernetes. Defining Kubernetes resources or Helm charts to deploy their application using popular GitOps controllers like Argo CD and Flux. Well, let me introduce you to a tool called CrossPlane. CrossPlane is a control plane built on top of the popular Kubernetes ecosystem. It is deployed onto a Bootstrap cluster as an operator, widely used Kubernetes framework, and uses third-party providers to interact with the popular public providers APIs, AWS, Azure, GCP, to provision cloud resources. The workflow could consist of, first thing, create a valid YAML manifest to declare one or many cloud resources defining their desired state. Check the manifest into the desired repository and create a pull. Use a GitOps controller such as Argo CD or Flux to automatically apply from the main branch of the repository to the Bootstrap cluster. These are then stored on the cluster as custom resource definition files, otherwise known as CRDs, that can be viewed using the kubectl command line. The crossplane operator then starts the reconciliation loop and the resources are deployed directly to your cloud account. Any changes made to the resources, such as manual configuration, CrossPlane will remediate the changes during the next loop to the desired state of the manifest. If a resource is no longer needed, create a pull request to remove the manifest from the repository and the CRD will be destroyed along with the cloud infrastructure. I mentioned a bootstrap cluster is initially needed, which poses chicken and egg type scenario. This can be provisioned however you like outside the crossplane workflow. This can be a very powerful way of managing the deployment of cloud infrastructure. Here, we can now leverage the GitOps model to define the desired state of our cloud landscape in a repository as clean, readable code. So now this poses the question, if infrastructure is now easy to deploy using GitOps method, could developers not just write manifest? Would this not pull all the platform and the DevOps engineers out of job? Oops. Well, not exactly. Crossplane is designed to allow platform teams to create abstraction APIs for resource lifecycle management. So developers can request or create resources with their chosen parameters and not need to know the complex configuration underpinning the resources. You can create this abstraction and climbs by creating the following resources. Composite Resource Definition XRD is used to define new types of composite resources and claims. This is where you would require or create the abstraction to hide the implementation details and only expose variables you want to the end users to configure. Composite resource claim. A claim corresponds to a type of composite resource. This is what the end user would use to define the chosen variables for a resource. I found this can be a bit tricky to understand, but the documentation will help you clarify certain things. So composite resource claim XRC that a developer would apply for a database would typically look like this. Developers now have an easy way of deploying and requesting the cloud infrastructure they want to consume for their applications. The platform team now still have the control over what is deployed and defines what resources can be used and what valid configuration options are available. Now the pros: GitOps deployment for cloud infrastructure. No more diff between infrastructure code and what is actually deployed to the cloud. The source of the true state is what is stored and declared in Git. Cross-team collaboration is easy for developers to adopt and request infrastructure. The platform team still has control over the desired configuration options. Easy to read declarative YAML files. Large open source community and is a CNCF incubating project. Cons: the Bootstrap cluster needs to be provisioned and maintained outside the CrossPlane workflow. Not all cloud resources are supported by each provider. Be expected to contribute to the community if there is something you need. Relies heavily on Kubernetes being the de facto deployment method for years to come. In conclusion, if your teams do choose to adopt CrossPlane, you will be using cutting edge technology, which will come with some challenges. In return, you will have a solid method for deploying cloud resources using the ever popular GitOps method. Could this be the future of infrastructure as code? Well, time will tell, as with any tool in ever changing DevOps landscape. It's time up to the adoption rate and community participation.